All right, guys, thank you so much for clicking on this video. And let's get started with our second problem under the binary search pattern. Today, we're going to be looking at a very simple problem. However, it's going to be a good starting point for us to start utilizing binary search. So the question here is find boundary using binary search. And the problem statement says that given an array ARR with Boolean values, return the index of the first true value found in the array. If no true value is found, return -1. All right, so the question is pretty straightforward. It is giving us a array with Boolean values, true or false, and then we need to return the index of the first true value. There's one more condition here which I have particularly not mentioned in the problem statement because I want us to realize it and understand it. Let's assume that we are given this array here, and as you can see, all the false values are grouped together at the beginning, and then once the false values end, we have true values grouped together at the very end. So it's sorted in order in a way that all false values come first and then all true values follow. We need to find the index of the first true element. And in this case, it's going to be 2, right? And then the way we can try to understand this problem is that every time we find a true element in the array, we know that all the other elements that follow it will be true. However, if we find a false, we know that all the elements before it will be false. So for example, if I say that my pointer is now at the very first element, well, since it's the very first element, it is false. Now my pointer, let's say, is at the second element. I know that all the elements before this element are false, up to this point at least. It could be that the next element could be false, but I'm at least sure that all the elements before this pointer are false. Similarly, when I'm at true, now I don't know if the previous element was true or false. However, I can say with conviction that all the elements that follow this index will all be true. So with this in mind, there's a simple pattern here. We can see that the array is sorted. We also know two assumptions. And we know that this could easily fall in the binary search pattern. All we have to do is start from the two ends of the array, and then each time try to find the middle element. Now, if the middle element is false, we discard everything to the left and the current element itself. If the element is true, however, the current element could be the first true element, although there may be other true to the left of it. So in an interview setting, if you're given a problem like this, let's see how you would walk through the problem and the solution with the interviewer. So given that we have this example, we have two use cases here. Every time we try to find middle element. So the algorithm would go something like this. Find middle element. Number 2, check if middle element is false. So if middle element is false, what do? We disregard anything to the left. And if it is true, we know that this middle element could be the first element, first true element, although we can disregard the elements to the right, because we know for sure that they are all going to be true. Now that you have presented the interviewer with some simple algorithmic steps in your mind, you can go ahead and start the coding part. So let's assume that in most interviews you'll be given a function to implement. So let's say that we can call it, because this is JavaScript, we could call it find boundary, and then as in the problem statement we are given an array, and now we need to simply follow our binary search template. Our first step here says find a middle element. So we'd go about trying to find the middle element. So for that we need to initialize two boundary pointers. So we say let left equals 0 and say let right equals array dot length -1. Now that we have these two boundaries set, we're gonna start a while loop and we're gonna run it until our left pointer either converges to the right one or the length of the value becomes 1. Now in each iteration we try to find the middle element, which, by the way, if you remember, is just going to be left plus right over 2. Notice that I'm only using simple bounds here, and then I'm not trying to go with the more complex way of finding the middle element, which was to do a left minus right over 2 plus 2 plus left. This is another way of doing it if we are not sure about the integer overflow, but in this case I'm just going to use the straightforward way of finding the middle element. Now that I found the middle element, I want to check if my array of mid is true or false. Now if it is true, then I am going to set my boundary index to the middle. Now if it is not true, then I'm going to set my left pointer to mid +1. So let's go with what we usually do in binary search, and that is if we found the middle element, we would simply update our right pointer to say mid -1, saying we're going to disregard everything to the right because we know that all elements to its right are going to be true. Right. There's one more thing that we need to do, but for now let's focus on our binary search template. Else we know that the middle element is false, then we're going to update our left pointer to mid +1 because we know all elements to the left are false. Now that we are here, we realize that we have completed our binary search pattern. However, this does not solve the purpose of the question. We are missing one more thing here. Now, usually we would return a -1 here, right? But in this case, we are not returning anything because this right here, the array mid, this could be the first. This could either be a first true, so this could be first true element, or it could not be the first true element. We don't know that for sure, right? And so there's only one way to figure it out, and that is to use, well, an additional variable. Let's set our boundary to -1, and we'll use this to represent the index of the first true element. By default, we're going to return boundary. However, when we know that our middle element is true, anything to the left of it could also be true. So by default, we set boundary equal to mid, which is the index. Now imagine what happens when you have your array mid as true. You're setting the boundary as the index itself, and then you are updating your right pointer equal to mid -1, right? So assuming that all elements to its right are going to be true, meaning every time you're going to get to the left part of the array. So you're moving further and further towards the beginning of the array each time you are setting the right to mid -1, which essentially means you will eventually find a boundary which is of the index of the first true element. Let's try, now that you have shown your code to the interviewer, you would have to potentially walk through an example. So let's just walk through this basic example, right? And I would suggest that you do a walkthrough just like this. Once you've written your code, you're going to go to a separate sections, start a multi-line comment, and start approaching the problem using any example. In this case, we're going to use the default example. Let's say our array is this one, and then so when we pass it to the find boundary, the first thing it's going to do is it's going to say that the left pointer is here, and then it's going to say that the right pointer is here. Now during our first iteration, it's going to find the middle element as this one, right? And then it's going to say if it's true or false. It's going to check if it is true or false. It is indeed true. So what it's going to do is set the right pointer to mid -1, which is shifting it directly here, and then it's going to update the boundary, right, to 2. All right, and now that we have our left and right pointer here, just so it is easy for you to identify what index is which one. This is index 0, this is index 1, this is index 2, index 3, this is index 4. And because our middle element's index was 2 and the middle element was true, we have updated our boundary as per line 30. And then now in our second iteration, we again are going to try to find the middle element, and in this case the middle element is going to be the right element itself. And so we're going to check if it is true. It's not true, so it's false. So then we have to update our left pointer to mid +1, which would basically be somewhere here, right? Mid is 1, mid index is 1, so 1 + 1 becomes 2. So update it to 2. So now our loop cannot continue any further because left is not less than equal to right. So we're going to end up returning 2. So as you can see, we were easily able to walk through an example without ever having to run our code. And this way of trying to walk through an example is really clear and intuitive to the interviewer, and it will be helpful for you to think through an example as well. Just one last corner case that you need to cover is that whenever you have an array with all trues, right, your let's assume that this is your case 2, right, and let's assume that this one right here is all true, then you need to understand that your code is going to run for 1, 2, 3, 4 iterations. However, in most of the average cases, your code is going to take big O of log n time, where n is the length of the array, and the space is going to be constant, so we can easily assume that the space is big O of 1. Well, that was about binary search and using it in problems like find boundary, and we can actually use this same pattern in many more similar problems, and JavaScript is really handy here because we don't have to do a lot of stuff. We just need to initialize a couple of variables and run through the loop. Well, thank you so much for watching this video. See you in the next one. Bye-bye.